And I believe that everyone should be seeing the screen from the PowerPoint where I have the weekly meeting on the screen. So this is our week 5 morning meeting. And as you will see, I've added another meeting and I'll make an announcement of that after our session. I think we're going to try running these meetings also in the evenings if that's easier. But again, I'm totally open. If another day, another time works for you, we can add that or change one of the times to that. So I'm all about giving you options to take part. So this week, we're looking at the heart. But before we start talking about the heart, I wanted to kind of go through a little bit. Ooh, that's fancy animations that are there. I never know what happens on these screens, which is probably concerning for everyone involved. So let's see if I get the screen that I want. So this week or in this session, I was hoping to go through a little bit more about the exam and lab practical that we had last week, hear your thoughts about those, and tell that if it felt like a lot, do not worry. There's kind of a few ways how we can kind of get back to it again as well if something didn't go exactly the way you wanted or you didn't get the points or the grade that you were aiming for. So there's absolutely always a way to come back to things and make sure that you get the grade that you're aiming for. I also want to mention what I mentioned before about the missing assignments, or if you need to retake assignments, I am open to that. And then we'll spend some time on this week's module. And really this week we're doing a lab that's a little different. So there's some technical things that come with that. So I want to mention a few words about that and just make sure that you have all the information you need to succeed on that. And then we'll review the material from this week's chapter. I do want also that you have a chance to ask questions. So questions are not only at the very end of this session. You can ask questions at any time, even though I've added it here to the end. That does not mean that you couldn't just shout out. You can unmute your mic and speak up. You can post on the chat or any other way you can get hold of me. And if you're wondering why I'm looking to the side, my cat decided to give me a bath, which always feels a little creepy. I'm also expecting that I might have exterminator coming over. I have some animals on the attic, which I'm not super pleased about. So if that happens, I'm trying that not to interrupt our session, but if that happens, we'll just take a really quick 3-minute break, and I'll let you know if that comes relevant. But I really want us to do this session, so that's a side thing. If that comes to be, I'll let you know at that time, just so you don't wonder if I'm looking around. But I think we should start with just me mentioning, like I said at the very early on this video, that I'm all about finding times, finding days, finding ways how we can make this work for you. And a few students were saying that maybe the mornings are not ideal for them because of their work pattern or things like that. So I've added also an evening session for these Wednesdays. I think we're going to try to keep it for a while. If I'm alone there, then probably we'll reassess if we keep those going. But these morning sessions, as we've had them, they'll stay as they are. But I'll probably try to add the evening session as a regular thing, not just for this week. And I'll make an announcement of that, like I said, on the Canvas course in a few moments' time after our session. If there is another day, if there is another time that works for you and you would like us to kind of have a look of that, do let me know. Of course, I won't be able to facilitate 20 different times, but I will be able to facilitate quite a lot. So these can be either group sessions as this one, or they can be one-on-one sessions. So I'm here for you. I know that emails and the Canvas messages, sometimes they do get a little bit, I end up a little behind those, but I do want you to know, even if there was a delay, it does not mean that, oh, you missed a chance to react on something. I recognize that there's a lot going on, and you might have to wait a couple of days. And if you have to wait a couple of days, I always try to take that into account with the extensions for the work to hand in. So I'm here and I want to make this work for you. In terms of the last week we had the exam 1 and lab practical 1. And I think that quite a few of you did really well on the exam 1. There is still, I need to finish a few things regarding the grading. There's a lot of manual grading as well. So even though you got the computer assigned grade, I go through every answer manually. And if it's close by, and sometimes that computer's software kind of doesn't give you points, even if you've been really close and I think you deserve, so I'll manually go and change those. I should have all of that done by the end of this week. And the reason why there's a little bit of a lag is that I want everyone to get the same kind of standard of what I accept and how I accept, so that it's not dependent on my mood. So I've gone through them a couple of times now, and then I'll release the final version to everyone, just to make sure that everyone's getting fair, similar treatment. But I want to say a few words about the exam first. I think that looks really good. You guys did really well. Like you remember, it was an open book test and there was no need to use the responders. I probably should have highlighted that a little bit more. So some of you were stressed out when you didn't need to be about that. But really, I'm all about let's keep things easy and let's keep things working for you. So unless I say something that you absolutely have to do it that way, consider it that then you can do whatever works for you. For these tests, I think that because there's so many questions and sometimes there's time as well, like in the practical, for example, that eliminates that oh, I would have to have you hide your notes or use the responders. That does still fairly assess what you have learned and how you are learning. So if you feel that you were kind of unfairly putting the bar really high for yourself by doing it as a closed book one and using the responders and so on, and you feel that might have affected your grade, you can reach out to me and I'm happy to have a look what we can do to kind of assess that it is same and fair conditions for everyone. But like I said, the lab practical, I think that was pretty intense. And I'm going to be honest that lab practical was set up by someone else than me. I think that, first of all, that was a little tough one. And second of all, the automatic grading system is really harsh on that in terms of that it kind of any slightest spelling error or any slightest hiccup on that, you get penalized quite heavily, and that's not what I want. So the grade that you might have initially gotten, it probably is going to go up once I'm working through that. And if still at that point, and I have an idea where we're at, but if at that point you feel when you've gotten your final grade back, and again, I'll make an announcement of that it wasn't what you expected, it wasn't where you want to see yourself heading, there's a couple of different things we can do to kind of ensure that if something didn't go your way, it doesn't affect too heavily on your final grade. So what I'm trying to say here is that fear not, we'll figure out what works for you and we'll figure out a way to make this course work for you. And once I have gotten everything graded and I make that announcement, I'm totally happy to do also reviewing of your either exam or lab practical. We can do those as one-on-one. So give me a shout out at that time and I'll set up a time that works for you with you. I'll coordinate that so you have a chance if you are wondering, oh, where did I miss the point or want clarification of some concept. And there's been few cases where it's been kind of justified as well to go back and reattempt that. So if you feel that you're in similar situation as that you would really like to have another go, another crack at those, I am open to discuss that and have a look of that. I don't say by default that everyone gets to do it, but don't feel that you should be hesitant to ask. I really, like I said, want you to have a chance to put forward your best work, and that to be the work that counts towards your final grade. So fear not, and this is not something where I'm aiming to catch you out. I think that that's all I can think of about the exam and lab practical. I'm glad to see you're still here, so that means that you survived it. Does anyone have anything that you want to share or comment in a public setting about that? Or if you want to talk about it later on, I'm also going to stick around here after our session, and I'm also going to be available for one-on-ones or then communicating through the course messages. So was there anything that any one of you, was it that you want to share? Was it too tough or okay, or?
I just had a question. So will all the lab practicals be that fill in the blank? Is that how it's going to be?
As far as I know, yes, but I will go and check that for you. But as far as I know, that's the format the course coordinator has set on it. But let me check that, and I will confirm that also in an announcement.
Okay.
That was a good question, and I'm not ignoring you. I'm just writing it down because if I don't have it written down, I'll probably forget it. Any other thoughts, questions? Like I said, I'll check that, but I do think that at this point that the plan is that they would be all similar to that, but I'll confirm that one way or another through an announcement as well. Anything else? Oh, I'm very grateful. Thank you, Janessa. The study guide, I do get it that it was a bit of a laborsome when you have those empty gaps and always they don't make sense. But if you work through that, like I said with the video, you have every single answer. So I'm very glad that you felt that that helped. Thank you for that comment. Okay, well, I'm glad to hear that that worked for a few different people. I'm always a little bit doubtful that what is worth keeping and doing. So if you feel that something doesn't work, feel free to also say that, so I won't waste our resources on that. But we'll keep the study guides then. My goal is also that the study guides are not helping you just now, but when you move forward, you have something that you can go back and kind of refer that these were the key points of this topic. So I'm very grateful for that feedback, and do feel that you can also say if something doesn't work, I won't take it personally. I've done this for a while. So anything else? If there's nothing else, you can always shout out even later on. I'm just gonna move on so that we get through everything, but we can always come back. So feel free to shout out or post to the chat. The other thing that I wanted to really take a little bit of time just to remind, because I've said this before, and I just want to make sure that everyone gets to hear the same thing, that if you have missed any assignments or some of the assignments didn't go your way, and really you feel that, darn, I would like to give it another go, or I would like to get a chance to go back to something that I missed, I am open to that. So again, just message me directly with specific details what assignment that is. If you just say that, oh, the lab that we did, I really need something more concrete because I'm gonna be going through those, and there's sometimes a lot of those requests. So if it's very vague, I might not get to it as quickly. But the best way to do those, even though I know that it's super easy to speak to me like this, and I'm always all about that, if you put it in writing, I won't look past it, I won't forget it. So that's why I'm all about those course messages. I do get it, and I do apologize that sometimes it takes a little longer than I would like for me to get back to those. But again, If it takes me longer, trust me that also gives you longer in terms of extension, or in terms of if there's something that you've been needing an instant response. I won't then be like, oh, you just missed out a chance because I didn't answer to you, too bad. No, I'm all about realizing that you guys are as well busy. So feel free to message me about those if there's any missing assignments or want to take retake assignments. But before you do, try to give a little bit of reflection. That's just for you, not for my behalf. That why would you want to do that? Is there something you want to do differently? Is there a different kind of strategy? Maybe it's that you've just learned how to do those assignments. I think that 90% of exam taking and assignment taking is technique, and the 10% is actually knowing the stuff. So it is a skill to take exams. It is a skill to take assignments, get those points. So just figure out what's the angle, how you're going to tackle that. And because we're kind of building more and more and more material that you might need to go back if you decide to go down that route, try to have a chance to kind of quickly review that material that is going to be involved with that assignment, so that you're not just wasting your time, or you're not just putting too much labor for yourself by going through everything at that very moment. So all I'm saying is that let's make it work for you. That was a very long-winded way to get. I'm just looking also at the time. If you have any questions, like I said, with anything, shout out. I'm not trying to not give a chance for that. I'm just mindful that I want to go through everything. This week, we have Learn Smart and we have the quiz. And we have the practice anatomy. Those are all elements that you're familiar with. So the Learn Smart was where if you just did it, you got 100% for that, full points. Quiz is like any quiz. You can get various different points on that. And then the same for the anatomy practice. But what's different this week is that we've got 2 labs that are taken in a little bit different way than we've been taking labs before. I don't know if any of you has already had a chance to try those. And if any of you who have tried those have found it challenging or stressful to get in there, if not, that's great. And you can just let me know that, no, it's not that hard. If you have not had a chance yet, I'll just give heads up that because it's a little different how it's done, there might be some technical hiccups that you run into. Again, if you can't make it by the deadline, I understand this is the first time we're taking these labs in this new format. And I am willing to work with you on that, but just kind of be aware that there's a little bit of tweaking on that. And I'll discuss what you need to know if you have not had a chance to do the lab. But if everyone here has done the lab and feels that it's super easy, just we can skip through those parts. So feel free to shout out. There will be few other labs that we're going to be completing on the same format as this week's lab, but most of them will be as you've been doing labs before in the Connect. It's just that I want to make sure that the first time that we do something new. Okay, you were not able to pull up the lab. Thank you for letting me know that. Let's go through a couple of ways what might have came as a hiccup on that. That helps me to know that that's something that it's not super easy, at least for everyone. And I'll try to give you a way how you can make sure that to work. And you did watch the video. Okay, so let's have a look. And if you are still not after with what I'm going to propose and what I'm going to show, able to access that, what I'm super happy to do, I'm super happy to also do these really quick one-on-ones. You can just let me know this time, this day works for me. Let's do really quickly, sit down and have a look. Why can't I log in there? A lot of the time I'm fairly able, even though I have a lot going on, I'm able to move things around so I can be with you. So don't feel that you're alone with that. If you've looked through the video, I don't think I have any super big secrets that were not covered on those, but let's give it a go and have a look. What needs to be taken into account with the lab? If anyone has been successful with taking the lab, please don't hesitate to shout out. That helps others to know that it's also doable. But if I don't hear, I assume that no one has had a chance to take it, or no one has at least been successful to get into it. And that's actually the next topic that I wanted to talk about. So we're doing these 2 labs that we have for this week on this Phil's lab format. And this is really something that's a little bit older. I think it's a little bit antique thing from the past that that the publisher McGraw-Hill used to use, and it's slowly fading away. But these labs that we have picked from that kind of an old setup are so useful or so good that we still wanted to give a chance to do those. McGraw-Hill, the publisher of your materials, also knows that these labs don't work quite as smoothly as they should. So they have people and they have resources also on their help desk able to help you. So I'll try to help you. They'll be able to help you one way or another. We'll get you there. What normally happens if someone has challenges is that your computer is good and new, and these labs prefer old and clunky computers. But so if you are having any issues with completing these labs, you'll notice that there is a section that's labeled on your Canvas course as Help with Phil's Labs. There's 2 items there. Both of them are videos, and those videos have been prepared with the hopes that they would help you to get around some of the reasons why you might not be able to access those labs. But that doesn't guarantee that there wouldn't be some other reasons as well. So I'm just recommending have a look at those if you get stuck. But if you get stuck and those don't solve your issue, there's nothing that you've done wrong. There's many other reasons that might also play a role. So we'll work through those. In terms of the Phil's lab, the biggest issue that most students and most people who try to take these labs, including us instructors, face are to do with the fact that these have been built on an old Flash-based setup. And I don't want to go into computer geeking, although I am a little bit like into that stuff with my previous jobs and stuff. So Flash is format that is disappearing. I think they stopped supporting it at the end of this year, I'm wanting to say, in December. So it's something that a lot of previous work and previous ways of doing things online were built on, but now it's going out. And because it's going out, for a while, a lot of publishers, a lot of users haven't really put in effort on maintaining those resources. So it might be that they are clunky. And for that reason, you might run into challenges. Flash is disappearing because there's been some safety issues, security issues with that as well. But I do think that McGraw-Hill is pretty safe organization to work with. So you don't have to worry about that in terms of these labs, but in general, just to give you background. So the issues normally come from the fact that these Phil's labs are built on Flash platform. And what you need to do if you don't have a Flash, you need to install it. And even if you have it, a lot of the time, the biggest number of issues that we find when trying to access these labs is that you need to be able to enable those labs to be used and ran within the Flash. And sometimes that's a little bit tricky. Sometimes there's multiple things that you need to have a look of. So because Flash has had problems in the past, most browsers that you use for internet try to block the Flash outright. But there's ways to get around it. So if you get a notice that looks something like what you see here at the bottom left corner, that it says that you need the Adobe Flash player be able to view these labs, or that you need to get the latest version of the Flash player, or download the Flash player, install the Flash player, that's an indication that it's something to do with just the way the platform where these labs are ran. And let's have a look. There's two places where normally this Flash is stopped from running. And this is done, like I said, by the browsers for your safety. But what's weird is that you can be all clear on one spot, but then the other spot is where it all gets stuck. So what I've got here, I've got two places that I've highlighted. And I've got these little screenshots next to those. So these are little snippets of the screen that you would see on a website. And of course, every web browser looks different. These are just the ones that I used, and you'll actually see also what I have saved as my favorites, or as my links on the saved files. Please don't share that with others. I probably shouldn't have shown that, of things that I'm interested, or things that I do for a living. So when you have the web browser, at the very top, you have the area where you normally would type the web address, or that it gets updated as you navigate through the sites. At the very right end of that, there's usually some sort of a symbol. It can be a star if you want to bookmark a site, but also you can get some sort of a symbol of a lock, or a slash, or a red slash through it, that's showing that no, something has been now blocked. And it's not very visible unless you're really looking into there. So at the end of where the web address would read, at the end of that, there might be a symbol that's telling you that the Flash has been blocked. And unless you really know to look there, you might miss that. So you go to that area, and you click on there, and it will give you an option, allow Flash to run, or something similar as that. And go ahead with that, and that should be the first thing that should help you to move ahead with these labs. If that doesn't work, or in addition to that, you might need to look for the other end. Now, this time on the left-hand side end of that address bar. And again, there might be, I think one quite common one would be an exclamation mark within a circle. And there might be also a text, or just that symbol. And it's somehow trying to tell you that this is not a secure site to go to. Well, again, I think that McGraw-Hill, they're not the biggest crooks that are after you, so don't worry about that. You can trust them. So again, you would click on that symbol, choose from the drop-down menu that you allow the Flash to be ran. And I think that this is quite close to what you would see on that option B. So there would be that exclamation mark and saying not secure. And then from the next to the Flash, you might need to choose it to be allowed. I get it that these are just two of the most common ones, what do end up stopping students from being able to run these labs. There might be other reasons. And if neither one of these solves your problem, well, then we'll have a look of what else can be done. So don't feel that if these didn't work for you, that you've done something wrong. But these are the most common ones that students run into. If you're able to access to the Phil's lab, you will see a screen that looks a little bit like this. And the challenging part on this is that these labs don't direct you immediately where you should be at. You actually have to choose the correct lab from this kind of table of context or simulation list that you have there. So you choose the lab that matches with the lab that I have listed there, or that has been listed there on your Canvas as the homework. Okay, this is where you were stuck. Perfect. I'm glad. So or it's not perfect that you were stuck. I'm so sorry for saying that. It's perfect that the lab software works for you. If you got stuck here, everything runs in terms of the technology. Okay, so I know that it's super confusing, and normally when you do homework or you do the lab, you just click on it on the Canvas and it starts the lab. But this one, that looks like a heck of a lot, and you actually have to go manually and try to find which one is the lab that we're doing. And I think that one of the labs that we were doing was the abnormal ECGs. So that's the number 30. So you would find that heading of that lab and click on that. And that activates the lab. So there's 2 labs that we're doing. I'll have a look at what the other one was. I think it was something to do with heart sounds or something. I'll have a look of it and I'll make an announcement of that if in case that helps. But the big deal is trying to find the right lab from this listing. And if you're clicking on that and nothing happens, then there's something wrong with the software. But if you are able to find the right lab and you click on that, you're good to go. So let's have a look of that, Tanya. What you are supposed to do when you click on to the Phil's lab, you've gotten to the point where I have the blue highlight, just the menu that we saw there earlier on. So like, I guess that's the 3rd step from the top. So you have to click begin and you have to click continue and then you have to click again. There's a text link, access Phil's labs. It really makes you to click multiple times to get there. Oh, I'm so glad it worked. Excellent. I'm super glad that we got something sorted out already. And then when you click the lab number 30, abnormal ECGs, it starts. And again, I think that it tells you something like how these Phil's labs work, is some basic info. Click on next on that. And there's a pre-lab quiz there. You can do that pre-lab quiz. I'm totally very appreciative if you're doing that, and it might help you to kind of get oriented to the activity that you're doing, but it's not necessary to do it. You will still get full marks for this lab, even if you don't do that. And then there is, after the pre-lab quiz, the actual lab exercise. And once you are working on that lab exercise, I would recommend that you keep the previous window open. That was open. It will open a new window where the lab will run. And when you get to the post-lab questions, or even while you're working through the lab, there will be a site in the Connect that's labeled as post-lab questions, and it basically asks questions about when you are working on that lab. What do you see? Or do you choose this? Or do you do that? And that's what counts as your lab assignment. So what I would do, I would keep them both open on 2 windows and work through them simultaneously. So the post-lab questions are really what you will be submitting. You don't have to do them within the Phil's lab, just make sure you do them at the Connect. You can do them on both. But if you run into any issues, if it's confusing, let me know. I'm so glad that at least we got 1 student on their way. I know I've taken a huge amount of time with the just basic technical stuff, so I'm going to move ahead and try to make sure that we have time to also cover the material from this week's chapter. But do we have any questions about this lab setting, this Phil's lab that we're doing on this week? The thing is that you don't want to just skip these labs, because we will use the same platform on few occasions on this course. Not a lot of the times, but a couple of times. The last slide that I have there is the contact details for McGraw-Hill's technical support, and they know that these labs are a little bit of a nightmare in terms of students accessing them. So they have people there who are used to solving these for you guys. There's their phone number, 800-331-5094, where you can phone, and honestly, they'll work with you. It's not to feel that you've done something wrong or you're not getting it. It's that their platform, how should I say it without being too judgmental? It's not ideal how it's ran. So if their product is not perfect, they know it as well. So don't feel that it has anything to do. Okay, now we get to this week's chapter and the key points that I want to discuss about that. Before we jump into that, do you have any questions? I feel like I've just talking about of the exams that we took, or the practical exam that we, or lab practical that we took, about the accessing labs, or about the previous assignments, how to retake those, anything that I've been unclear. If I don't hear anything, I think that that's always a good sign, but feel free to also shout out if there is something. So what I'm trying to do now, and let's see if I'm successful on that. I'm trying to make sure that we move on to a different screen. And let me just share that. Oh, I didn't mean to click that. Sorry about that. This looks more like it. So what you should be able to see should be that I'm trying to share with you a PowerPoint of the lecture material or the lecture slides for this week's chapter on the heart. And you should be now able to see on your screen kind of a first slide that's more of just an introductory one, talking about cardiac definitions for the heart, what sort of definitions are provided in various textbooks, various resources. If someone is not seeing that, if you're still seeing just that weekly live online meeting slides, that's not what I'm trying to show you. If you are able to see these definitions, you're at the right place and I'm sharing it correct. I noticed that I haven't yet I know that I haven't yet uploaded these lecture videos on this week's module. I actually am doing it right after that. It's just that it took took a lot of bandwidth and a lot of time for those to upload on YouTube. So I quite didn't finish them before this session, but they will be uploaded there in the next couple of hours. So my computer is running on that and burning the bandwidth with the YouTube on that. So they should appear there really, really soon. So unless I hear someone shouting out that you're not seeing the material that I'm trying to show, I'm going to go quickly then through what this week's material is all about and what are the key points. Really, I'm pretty passionate about this week's chapter on the heart because that's what I've done most of my research on. So most of my life, I've actually studied heart, and I've studied heart in few different ways and in few different modalities. And to be totally honest, I've made a living out of studying 3 blood vessels in a heart. And that's all that I was paid for, to focus on those 3 blood vessels. Of course, their consequences are a little bit bigger, but that's why I'm pretty excited about this week. And this is something that I really, really do enjoy. So I hope that I'm able to convey a little bit of that excitement to you as well. So what we will do this week, I'm just going to go through anything that's not super important. There's some review of different cardiovascular systems, different adaptations to the heart. This is not the key point. Different animals approach the challenges and need for having blood, or not always even just blood. It can be some sort of another kind of a fluid that gets circulated within the animal. But that's not what we're focusing here. We're not doing comparative anatomy as a main thing. I just think it's nice to start with that. What we are focusing is a human heart. And there's few animals that have a very similar heart as humans do. For example, pigs. So again, a lot of the time we use pig hearts and pigs as a model organisms for studying humans. I've done a lot of research on pigs, putting them into MRI scanners and scanning their heart. The reason for that is that you're allowed to do certain things with pigs that you wouldn't be allowed to do for humans. You cannot cause a cardiac arrest. You cannot cause myocardial infarction to a human. That would be very unethical. For a pig, that's sometimes allowed if there's a good reason in terms of that advances the care of humans. So that's why we use sometimes some other animals, but they're very similar to humans. So human heart, as you see there, we'll have a look of that a little bit more, but I want us to be familiar about 2 kind of circulatory systems, if you wish. If you look at the heart can be divided into 2 parts. One part is on the right-hand side, and that goes into pulmonary circuit or pulmonary circulation. Pulmonary refers to the lungs. So the first half of the heart is all about passing blood to the lungs. And that blood that goes into the lungs is usually low in oxygen. So we talked last time when we looked at the blood in general that when blood is low in oxygen, it often appears a little bit darker, kind of purplish in color. Not really blue as in these diagrams, but you can tell even visually that there's not a lot of oxygen present in that blood. Well, we take that blood to the lungs, and that's where the gases are exchanged. And all of a sudden, the blood does become rich in oxygen, so oxygenated. That blood appears bright red, and now it returns back to the heart. So this loop where blood is sent from the heart to the lungs, and it comes back from the lungs to the heart, that loop is known as pulmonary circulation. The other half of the heart, the second loop, if you wish, is the loop that transports blood to the rest of the body. So rest of the body, we describe that as a systemic circulation or systemic circuit. So really, your heart can be described as having two different hearts beating as one. One half of that heart is all about taking blood that's low in oxygen to the lungs and bringing it back as high in oxygen. The other heart or other part of the heart, if you wish, and that way also the other loop, is all to do with having systemic circulation, taking that blood that's rich in oxygen to the body, letting the oxygen be taken up by the tissues within the body, and then bringing back the blood that's now low in oxygen back to the heart. So there's almost these two loops, two parts of the heart, two different circulatory systems going on. So know the pulmonary and systemic, what's the difference between those? And again, when I'm going through these key points of this chapter, if at any point something doesn't make sense or something is stuff that you want to hear more about, give me a shout out. Next, I have just talked about some anatomical landmarks and where your heart is located. So your heart is located roughly in the middle, just slightly right from the middle at the very front of your chest cavity. And often when you talk about what's the best way to get to the man's heart or the woman's heart, you hear about cooking and all sorts of things like that. Really, that's not the case. The best way to get to someone's heart is between the ribs 2 and 5. So that's what I say for the Valentine's Day always. Heart is located above the diaphragm. And then what I've done here, I've shown a diagram that's kind of a nice, pretty drawing of what a human heart looks like. However, I'm not expecting you to be able to draw nice, pretty drawings. I'm going to show you an easier way to study heart. But what we will notice, even on that easier way, that heart is divided into 4 different parts, 4 different chambers. At the top, there's atriums, and at the bottom, there's ventricles. And there's one for the right side and one for the left side. And on this, remember that we always talk about the right and left as it relates to the patient, as it relates to the body that we're looking at. So patient right is what we call as the right for the heart as well. So it's a lot of the time a mirror image from what we are expecting to see. And like I said, I showed there nicely what fancy drawing of the heart would look like, but we're not going to be focusing on the fancy drawing. What I want us to focus instead is a box. This is a heart. So if you're ever asked to draw a heart, you can simply draw a box that you divide into 4 little boxes inside. This is heart. This is all I would, if we were taking traditional exams in a classroom, all I would ask you to do when I ask you to draw a heart. So you'll notice heart has 4 chambers. The atriums at the top, so more superior parts of the heart are atriums. You have right and left. And at the bottom, so inferior part of the heart, are our ventricles, again, right and left. And when we are following the flow of the blood, we can study the flow of the blood through the heart, through that fancy drawing, or we can use this kind of a rough drawing of the heart. Both will end up showing us the very same parts. But when you are asked that where does the blood come to the heart, well, blood always comes to the atriums. Whether it's right or left atrium, that depends from which one of those circuits or circulations that we just had a look of the blood is coming from. So which one of these, are we talking about pulmonary circuit? Are we talking about pulmonary circulation? Or are we talking about systemic circuit or systemic circulation? That defines that is it right or left atria where the blood is coming to. So let's get back to our drawing, which was the box that showed the heart. So what we often do to study the different parts of the heart is to follow the flow of blood. And we are going to start with the blood that's coming from the systemic circulation, and it has very little oxygen in it. So this is the blood that's coming from the tissues, and it's entering to the right side of the heart. You remember that right side of the heart was all to do with our pulmonary circulation, pulmonary circulation. So blood arrives to the right atrium, and there's a few different vessels from where the blood would arrive. It could arrive through, most commonly through superior or inferior vena cava, and we'll have a look of those later on. But blood arrives to the right atrium. Then from the right atrium, blood travels to the right ventricle, and there's a valve, so a flap that regulates that the blood can flow only one way from the right atrium to the right ventricle. And once blood has reached the right ventricle, it gets pumped all the way out from there, from the heart to the pulmonary trunk. And we'll have a look of these vessels a little later, but at this point, all you need to know that from the systemic circulation, the blood, which is low in oxygen, comes to the right atrium, travels then from there to right ventricle, and out from the right ventricle to the lungs. Now this blood is rich in oxygen, so it is actually reoxygenated, and it comes back from the lungs. We learned that blood always comes to the heart, to the atria. So blood arrives from the lungs to the left atria, and from the left atria, it again travels through a valve, which facilitates one directional blood flow to the left ventricle, and then it gets pumped out from the left ventricle to the systemic circulation. These arrows are now all same color, but you would know that on the right side, there's this kind of more of a blue set of lines because there's very little oxygen in that blood. And on the left side, the blood would be bright red because it's rich in oxygen. So that's how blood travels through the heart. And we can look through the same flow here on this fancier diagram of the heart. So you'll notice that there's actually two different arrows coming into the right atria. This was blood that comes from the systemic circulation, low in oxygen, that's why it's blue. So it's deoxygenated blood, if you think back to our previous chapter. From there, it has to travel through a valve. So function of a valve was to make sure that blood can only travel to one direction, not come back, not leak back to where it came from. So there's a valve between the right atrium and right ventricle. Once the right ventricle is full, we prevent blood from flowing there back to the right atrium. It has to go up to the lungs through a pulmonary trunk. And you'll notice that there's another valve there right before the blood leaves the heart and leaves the right ventricle. There's a valve. So that prevents that blood doesn't return from the lungs as deoxygenated, low in oxygen, back to the right side of the heart. This is a one-way system, and it's thanks to these valves that it remains as one-way system. Now, we got earlier on to this view where blood was returning from the lungs as oxygenated blood, rich in oxygen, to the left atria. Let's have a look. On this diagram, it looks like there's only one hole or only one path for the blood to get to the left atria. Actually, there's 4 different ones, but for the sake of simplicity, we can just imagine that it's one single hole. Once the left atria has been filled with oxygen-rich blood, so blood that returns from the lungs, it's now rich in oxygen, it travels from the left atria to the left ventricle. Again, you'll notice that there's a valve. So again, we're facilitating that the blood cannot return wrong way back to the lungs as oxygenated. That would not serve any purpose, and that would be a problem. So instead, blood has to leave the left ventricle through yet another valve, and it goes to the systemic circulation. It goes to the systemic circulation through aorta. And again, we'll talk about these vessels of the heart, big vessels, a little later. But what I want you to know at this point is just the flow of the blood through the heart as such. So that's one key concept that I want you to know. What else do I want you to know? I skipped through a few things here. What I want you to see, oh my goodness, fancy animations, is that heart is enclosed in a sac within its chest cavity. And that sac is there for a purpose. That sac ensures that the heart is able to move regardless of all this other stuff that is around it. So there's lungs around it directly underneath. There's our diaphragm. So we're putting it into a sac. You can think of it as a double Ziploc bag so that it's able to move without much resistance to it. The other reason for putting things into sacs in the body, you remember the different cavities of the body were often enclosed into sac-like structure. That's to prevent any infections from spreading from one part of the body to another. So that's another function for that. So that's what I wanted you to know about the heart. Kind of just to remind ourselves, remember that heart, that we have had a look, it's mainly muscle. There's muscular walls, and that was a special type of muscle. We have looked at these 3 different types of muscles: skeletal muscles, smooth muscles, and cardiac muscles in the past. You remember that skeletal muscles were the big muscles of movement that we look. Bodybuilders have very pronounced skeletal muscles. Smooth muscles were around blood vessels and intestines, kind of involuntary ones, controlling the flow of blood or controlling the passage of the food through the digestive system. And then we had the cardiac muscle, and you only find cardiac muscle in the heart. And this muscle had certain adaptations. It had a lot of branches. It had these intercalated discs. This is because we want to make sure that every heart muscle cell is connected to another, and it's easy for them to pass messages from one cell to another. This is how we ensure that the heart contracts as uniform, so there's no different heart muscle cells that do their own thing. We want it to be coordinated. So that's something to say about just the heart muscle. That should be kind of revision at large for what we know from the past. I think that we have had a pretty good look of the basic anatomy of the heart. One, if you want to know, like a heads up, one part that I always ask that surprises students, and I think it's an important part to know, is that our right and left ventricles are separated by a wall that's known as interventricular septum. So what the word interventricular septum means, well, we'll notice the part ventricular. It separates 2 ventricles. If it's inter, it's in between the ventricles. And when we talk about septums in the body are some kind of walls or parts that separate 2 parts. So you'll notice the interventricular septum there as a bottom label, and I've also highlighted it with this kind of a grayish line. So know that part and know the name of that. If we go back to what we saw here as a simplified drawing of the heart, the interventricular septum would be separating the right and left ventricle, so that one single line between these two, and I'm trying to figure out if I can draw somehow here, but I'm not having too much of a... Let's do laser pointer then. So what you'll notice is that this wall that we see here, separating the right and left ventricle, that's the interventricular septum. So sometimes that throws off students when I ask about that. So on here, you would see it on the fancier drawing. It's this wall. That wall has certain special reasons why we want to know it, but for now being, as long as you know that such a thing exists. Let's see if I can get this back on track. The next thing that I wanted to talk about with you guys was different kinds of valves that we find. So I mentioned that the function of these valves was to make sure that the blood flows in one direction through the heart. So we have atria and ventricle. Atria and ventricle are separated by AV valve. AV stands for atrioventricular valve. So it's basically telling where it's located. And we have one on the right side and one on the left side. So that's what separates the atria and ventricle. The right AV valve can also be called sometimes as tricuspid valve. The tricuspid tells us that we have three cusps. These leaflets of the heart are known as cusps. They look like a little bit, I don't want to say cups, but like little leaflets. And there's three of them, so we call the right AV valve as tricuspid. On the left side, we have actually only two leaflets on our AV valve. So we call it bicuspid, so only two. The other term that you sometimes see for this valve is mitral valve. So any of those three can be used to describe that on the left-hand side, and on the right-hand side, any of these two read either right AV valve or tricuspid valve. On the left-hand side, left AV valve, bicuspid valve, or mitral valve. So really, the best thing to do is to learn all those. And remember, on this course, you can use your notes when you're taking the exam. So I would just make a really good diagram for yourself and add all the possible names for these valves. Well, there's two other valves. These were the valves that separated the atria and ventricle, but there's also valves that separate the ventricle from either the pulmonary circulation or ventricle from the systemic circulation. And we see them here. So this valve here separating the right ventricle from the pulmonary circulation, which would be going up here towards the lungs. And this other valve here separating the left ventricle from the aorta and then from the systemic circulation. So let's have a look at those. These are named very easily. It's going to be easy for you to remember. Pulmonary valve separates that from the pulmonary circulation. And aortic valve separates that from the aorta and then systemic circulation. So again, just things to be aware of, just things to know. I would know those valves when I'm studying. And if we go back to our simplified diagram of the heart, you would find these same valves here. I just haven't added them. Our right AV valve would be here, separating our right atria and right ventricle. Our left AV valve would be located here, separating the left atria and left ventricle. And the alternative names that we had were here for the right atria, right ventricle, separated either by the right AV valve or by our tricuspid valve because there were 3 leaflets. On the left-hand side, we had the left AV valve, or the other name for that was bicuspid valve, or the mitral valve. And then we had a valve that separated the right ventricle from pulmonary circulation. So that would be our pulmonary valve. And on the left-hand side, separating the left ventricle from systemic circulation, that would be our aortic valve. I hope that makes sense. I know that it's a lot of terms, it's a lot to take in, but really anatomy is all about just learning once this, and then you can write that way and use those same terms. So let's see what else we need to know about the heart anatomy. The other thing that kind of jumps on the physiology side is that we notice that the pressure, the strength of how hard the heart contracts and pushes that blood onwards within the pulmonary system or systemic circuit, those differ. So the pressure of the blood traveling to the lungs is, and this is a wrong way around. I'm going to have to correct this. So the pressure of the blood, so please ignore this. This I will have to change. It's the other way around. The blood going to the pulmonary circuit is low pressure, and blood going to the systemic circuit is high pressure. So please, please, please do not believe what I have marked here. This is incorrect. So we have rather low pressure on the pulmonary circuit and high pressure on the systemic circuit. That's because lungs are so close to the heart that we don't need to have a lot of force to pump the blood there. Also, blood comes very close to the lungs as a circulation. If it was pumped too strong, it would actually break the lungs and blood would leak into the lungs. So we only want to have low pressure there. For the systemic circulation, that's much larger. The blood travels throughout the entire body. For that reason, we need to have the blood pumped much stronger at much higher pressure to that part of the body. So I hope that makes sense, and I do apologize that on this review version, I had this wrong way around. I think that for the ones that I used for the lecture video, I had them right way around. But remember, pulmonary system has a low pressure and the systemic circulation has a high pressure. So that's the take-home message from those. I think that should be all that I want you to take away from this particular slide. Then I'm going through different kinds of grooves within the heart. These are good to know, but not necessarily the most key point. But if you're aiming for an A, you'll probably review these. And again, the names tell quite closely where these are. The final concept on this first part that I want to highlight is that we learned that all tissues require blood. Well, heart is a tissue just as much as any other tissue, and because heart is constantly working, it will constantly need blood. So there's a rich blood supply from the heart to the heart itself. And this is one of my favorite tough questions to ask from students. It is that what's the first blood vessel after the aortic valve? And often students are looking at these other blood vessels that we have high up here, and learning this is nice and all that. But the first blood vessel after aortic valve is actually the coronary arteries, and they're located right after that valve. So right at the very base of this aorta, right at the proximal end of the aorta. So these coronary arteries play an important role of making sure that the heart receives oxygen-rich blood itself. And these are the three vessels that I said that I made a living of by studying. And again, not necessarily the most important concept of the entire chapter, but if you're aiming for an A, probably one that you do want to know. So we have left coronary artery and right coronary artery. And left coronary artery then gets divided into left anterior descending and left circumflex artery. And then we have the right coronary artery. I will review these in more detail. Oh, can I go back in one slide? Sorry. Let me know which slide it was. I just kept going without noticing. Was that the one about the coronary circulation or? One more. Okay. Oh, was it this one? That's a lot of information. So don't feel like, oh, perfect. Don't feel like, oh my God, I don't know this by heart at this stage. What I'll show, these are the grooves, the little indentions on the external surface of the heart. So if you end up studying anatomy or even physiology of the heart, you want to know the landmarks. So this heart that we see here on the upper right corner is as if we were looking at the heart from the chest towards the chest, that we've opened a patient's chest. So we'll notice our right atrium would be here, right ventricle here, our left atrium here, left ventricle here. So let me get the pointer. I keep forgetting. So our right atria, our right ventricle, our left atria, and our left ventricle underneath. So the atria and ventricle are separated on both sides by something known as coronary sulcus. Another term that you sometimes hear being used for that is atrioventricular groove, so AV groove. So that's the first one to know. The second one to know is anterior interventricular sulcus. So that separates the two ventricles on the anterior side. So it's on top of the interventricular septum, which we saw earlier on. So that's a groove that separates those there. And then we had the posterior interventricular sulcus. That's on the back side of the heart. Let me see if I can get the slides to move. Now it should work. So on the back of the heart, between the ventricles, we have another groove. And because it's at the back, it's posterior and it is interventricular, between the ventricles. So remember, this picture now would be reversed because we're looking at the heart from behind. But really, like I said, this is good to know. If you're aiming for an A, good stuff to know. If you're just aiming for a pass, you probably don't have to worry about this. So it's all about what you're aiming for. And the reason why I went through these grooves is that they are where the coronary arteries lie. So knowing those grooves helps you to know where the coronary arteries lie. So our left coronary artery divided almost immediately. And again, this is only if you're aiming for an A, not something that you need to know if you're just aiming for a pass. Left coronary artery divided almost immediately into two parts. On the anterior side, it is anterior interventricular artery, just as its name suggested. So between the ventricles in that groove. And then we have another one that runs as a circumflex artery. Circumflex artery tells you that it goes around the heart. And again, it separates our atria and ventricle on our left side. And it goes all the way to the back of the heart. Let's have a look of the other blood vessel or other coronary artery that I wanted you to know. And that was our right coronary artery. That runs into the groove that separates our right atria and ventricle. So we just went through that groove. So that runs there. Sometimes you'll see different terms being used a little bit interchangeably. It depends, are we talking about anatomical naming system or are we talking about, for example, medical naming system? So don't get too thrown off if you see different terms being thrown around a little. Not only heart has arteries, heart has also veins, but we're gonna leave those for a little bit lesser of attention. In general, in body, veins are a little bit less regular. They're a little bit more all over the place. Heart is not quite as bad as other parts of the body, but you'll notice that there has to be also veins to collect the blood that's now low in oxygen, and some of them are good anatomical landmarks. So that was the bigger section of this chapter. On the other section, I basically will just discuss the electrical events that happen within the heart. And you'll notice that it's fairly similar to the action potential as we discussed with the nervous system. But you'll notice that the action potential within the heart is much slower than the action potential within the nervous tissue. That's because you want to give time for the heart to contract and do its job. If it's too quick, the blood wouldn't move because it all would happen too fast. So having that little bit of a slower passage of these action potentials within the cardiac muscle actually enables us to make sure that both atria and ventricle, all of the chambers of the heart, get a chance to empty from the blood when they contract. So blood has time to travel wherever it needs to travel. And that just discusses these slides, the events in a greater detail. But the take-home message from this is just to know that the cardiac action potential is much slower than the nervous system action potentials, which we have covered earlier. The other thing that I do want you to know, especially if you're aiming for a high grade, is how these action potentials travel through the heart. And I have some other windows open on my screen that you probably are not able to see. So just in case you wonder why I'm moving things around or why I'm not always able to see the same stuff that I keep telling you that we're seeing, that's because of that. So where does the entire heartbeat start, the electrical currents that control the contraction of the heart muscle? Will they start here at the pacemaker of the heart? From there, these electrical currents travel throughout the both right and left atria. So the upper part, the most superior part of the heart, these electrical signals travel there and cause the atria to contract. Once that has happened, we go to the AV node, which is where there's kind of a little bit of a delay for this action potential before it's allowed to pass. And from AV node, we travel with the electrical impulse down towards what you saw as the interventricular septum. There we'll also find other structures such as Purkinje fibers, and then this electrical signal travels throughout from the tip of the heart, from the apex of the heart, up the walls of the heart to cover the ventricles. And now ventricles contract. So you'll see that this difference causes that atria contract first, and once they start relaxing, ventricles contract. And once they start relaxing, atria contract. So it's kind of this synchronized pump where one is contracted, one is relaxed. And that's why we have the delay with the passage of the action potentials within the heart. And for that reason as well, we've got this relay node, AV node, where we stop the signal for a while before we let it pass onwards. So that's how the action potentials travel throughout the heart. I just discussed some clinical relevance ECG, and you'll learn a lot about that on your lab this week. Learning ECGs, it really is not very hard. That's actually quite simple, and that's a good skill to have. That also you can train in ECG reading, and you can make some good money with that. So if you're thinking of career options, sometimes we have a regular beat, sometimes we have irregular beat. Sometimes we have totally uncontrolled beats. And you'll learn to have a look of these different kinds of EGGs if you're interested. I'm adding some extra material on your materials, but that's not something that you have to know by heart. We also know that automated external defibrillator, AED, is one of the most useful things that you can do in terms of the first aid that actually can save lives. So that's what we use to try to re-establish the heartbeat, the electrical currents in a heart that's gone into fibrillation. There's a little bit of discussion of the nervous system control, and there's again comparing the action potentials and the passage of the action potentials in the cardiac muscle cell. Like I said, I won't go into too much detail of the ECG because you'll have a lab about that. But basically what we are doing, we're putting a bunch of LEDs across the chest so that we're looking at different parts of the heart. And we also have some control LEDs either in your hand and in your leg or ankle or wherever. And based on that, we're able to record those action potentials within the cardiac muscle. So what we're really looking at some summation of those action potentials traveling through the heart. And with these different LEDs, we can tell at which part of the heart those action potentials are taking place. And then we add all of those together and we get a wiggly line like this. And this wiggly line in a healthy heart, in a heart where we don't have any issues, is always alike. And we'll go through the different parts of this wiggly line, but the main thing here is to remember that different bumps and different depressions have different names. So let's see if I get back to the PowerPoint. So the very first bump that we see on this wiggly line is known as our P wave. Then we have three different, first depression, then elevation, and then depression again. We call this bunch of three as a QRS complex. And finally, we finish off with, again, our T bump here that you see, T wave. So the letters that you want to know in terms of reading the ECGs are our P, Q, S, and T. And these are the names that we always give to these similar bumps that appear at the similar points of the ECG. And measuring distances between these different bumps allows us to give different timelines for these different events in the heart. And we can look at, are these timelines what we would expect, or are they too long, too short, or are some of these bumps missing? And all of those would tell us if there's some sort of a clinical issue with an individual's heart. Again, I'm moving just screens to see if there's anything that I need to know. The term systole and diastole, those would be the terms that I would want you to know. So systole refers to the time or the period of time when the heart is contracted. Diastole refers to the period of time when the heart is relaxed. So atria are different from ventricles. So one is always in systole, one is always in diastole. So we go back and forth. And rather than saying that atria is contracted, we say that atria is in systole. When we say that atria is in diastole, we mean that that's relaxed. How I remember these is that I think of relaxation. What happens to that atria or ventricle? When you're relaxed, you dilate, you grow in size. So diastole comes from that. And systole is then the opposite of that. That's how I remember it, but if you have a better way of remembering, make up your own rules. We will review these most important parts of the blood flow in greater detail, but you don't have to at this point worry about those. Did anyone have any questions? No. Then we can listen to heart with stethoscope. There's two sounds, and we can associate those sounds. Often it's described as lap dup. And I think that this is one of your labs that you will be looking as well. These can be associated with closing of different valves. So depending on what sound is heard, that tells that what valve is closing. And if there's issues that the valves don't close correctly or they don't close at all of those can be heard with stethoscopes. So that's why your doctor will listen to your chest, and she or he will listen to your chest from a few different spots, that we're looking at different valves, that are they working, each of those four, the way they should. What was the cardiac cycle? Cardiac cycle is simply the period of time for a one heartbeat, how long it takes for a one complete heartbeat to take place. I think that I've explained it in a little bit wordy way there, but cardiac cycle simply tells you the length of time for one complete heartbeat. So from when the atria start filling, when they contract, when they relax, as the ventricles are full and contract, until we start that cycle again. So it's just one round of the events of the heartbeat. I hope that that helped. I'm glad that you shout out, because I sometimes go through this so fast. And then what else would you need to know? I talked a little bit about abnormal heart sounds. Like I said, I already mentioned the most important of that. Their amount of blood pumped depends on a few different factors. So we talk about something abbreviated as CO. That's cardiac output. That tells us how much blood is pumped out by a heart in 1 minute. So that's what CO stands for. And cardiac output, of course, depends on two different factors: how fast your heart beats and how much blood gets squeezed with each heartbeat. So cardiac output, how much blood leaves the heart in 1 minute, is dependent on the rate of beating, so the heart rate, and also the amount of blood squashed out on a single beat of a heart. That's our stroke volume, the volume of blood within the one single heartbeat. This is a formula that's kind of an important one when you start studying different elements and different numbers, and you can kind of relate that you can calculate different things. And if you know a little bit rules of math, you can go back and forth figuring out heart rate based on the cardiac output and stroke volume and so on. So what we'll notice is that your cardiac output can grow significantly if you're an athlete, if you take part on the physical exercise that's very strenuous. And that's about it for this chapter. I think we have covered in quite a bit of detail, probably a little bit more in detail than what I was intending, the heart chapter. But that's probably a reflective of the fact that I do really love this chapter. And this is something that if I'm passionate about it, you might expect that there's some questions about it in the exam. Did you have any questions about the key points of this chapter? I know it was a lot, and I will upload those videos that I have already recorded for you in the next few hours. I still want to remind you, it's not that you have to use it just because we've been asked to remind you that you do have the tutoring service known as Cranium Cafe. But in addition to that, I am so happy to organize one-on-one sessions, group sessions, organize extra live weekly online meetings like this one. I think that I already mentioned that we have set one for this evening. I haven't yet sent an announcement of that. So I am here to help you. Just let me know. It's not like you just have to study by yourself. You do have a teacher available. So let me know if you have any questions you would like to have another time when we go through things. If you have any questions, this is a really good time to shout out those. And I'll just put this up while I'm opening the floor to the questions that I think we have covered all of the things that I hope to cover today. But feel free to either type questions or unmute yourself, shout out things. If you don't have any questions and you're totally happy with the material, then we are done for today. So I'll be around for a couple of minutes if you have questions. Thank you. I appreciate you guys. I know that this was a lot to take in, but you did amazingly well. Very good job here. And like I said, there will be videos. Thank you. I really appreciate you joining me today. And what I'll do, I'll turn off the recording now in case someone has questions that they don't wish to ask on the record.